Okay, so let's talk about factoring binomials. Now, something I want you to notice. This binomial, which has two terms, notice both terms are perfect squares. This makes it much easier for us to factor. But here's always my recommendation. I know how to factor three terms very quickly and very easily. All I have to do is make three terms into four. I group them or pair them, and then it's easy to factor everything out. Yes? So that's what I'm going to do here. I'm going to choose to write this as three terms. Now, some of you are like, isn't there a shortcut? Here's the deal. If you don't understand the long way, then it doesn't help to know the shortcut because you may not apply the shortcut correctly. Got it? All right. So I have x squared, and in descending order means after x squared should come x to the first. Do you see any x's in the middle? Good. There are 0 x's in the middle. So here's how I write those two terms into three terms when they're both perfect squares. Make it into 4. So I'm going to do the first times the last, the lead coefficient times the constant, and I get a negative 49. Now, here's where I'm going to pause, because normally when we factor trinomials and we get to this point, we list all the combinations, don't we? But here's an advantage. And so here is the little observation, shall I say? This is a perfect square. 49 is a perfect square, which means more than likely the combination I'm going to use is the square root combination, 7 times 7. But since this 49 is negative, one of them has to be negative. Cool? And so now I am going to replace that 0x with a minus 7x, a positive 7x, and then minus 49. Cool? Now what? Group them, pair them. Here we go. First pair, taking out an x. Second pair, good. Positive 7. What do you get when you take an x out of the first pair? X minus 7. And you took a positive 7 out of the second pair. X minus 7. Looking familiar, right? Because this stuff you should already know how to do at this point. Because you're like, oh, we grouped. The parentheses are the same. I can factor the parentheses out. And what remains is this x plus 7. Good? Does that make sense? Okay. Recap. I'm taking two terms, which are both perfect squares. I'm making it into three terms. My observation is when I multiply the lead times the constant, I have a number that's a perfect square, which means more than likely the square root combination is going to work. But since this is negative, one of them has to be negative. And when I replace it, I just factor by grouping like I've done in the past. This is nothing new. Good? Okay, I have some examples coming your way. Stay tuned.